Hello, I'm Alan Dix. I'm Director of the Computational Foundry at Swansea University, but today I've come here as a human-computer interaction person to talk to you about designing user interactions with AI. Now, I come to that with quite a bit of personal interest. I said my background is in human-computer interaction, and I worked during the dot-com era on intelligent interfaces, and I'll show you a little bit of that later. Also, back in 1992, I warned of some of the dangers of gender and ethnic bias in black box machine learning algorithms. Sadly, well, gladly, it's taken a long time to actually occur. Some of the things I thought were going to happen quite quickly then, but sadly that warning wasn't heeded. Also worked even on things like genetic algorithms for early submarine design. So quite a range of work, but often at that sort of boundary between the user interface and intelligence. This is a diagram that I often use to sort of help myself think about it, but also talk about the range of things in this area. So I can't talk about them all today. But if I look at this diagram quickly, I'll just give a little bit, and particularly about the four quadrants in the middle. There are some uses of AI which are about the user-facing, the things that the end user sees. So some of that might be about using a sort of web-based interface, some of that autonomous car and the kinds of interface used there. There's other parts of AI which are really at the back end. They influence the user interface, the way people work, but it's more about perhaps evaluation, about how you develop things in the first place. There's a front-end, back-end difference. There's also some things which are all about AI helping user interfaces. So intelligent user interfaces, that's about having a user interface, perhaps a website, and making it adaptive. There's front-end things like that, but also back-end things like evaluation, looking at large amounts of data from perhaps, again, from traces, from perhaps web applications or other kinds of applications, and using that to improve them. There's also places where the user interface can help artificial intelligence. So maybe you have a system which is already, it's just bound to have a lot of AI in it, perhaps an autonomous car. And then your question is, how do you design things so that actually works well with people? But of course, AI developers are themselves people who need help. And the AI to interpret that, some of the set of the problems when you want to explain AI. So it's things in these different areas, but I'm going to focus particularly on the intelligent user interfaces. So this is things like perhaps an adaptive web interface that adapts to the user. That's where my focus is going to be today. There's a number of touchstone phrases I often use when I think about artificial intelligence. One of them is an alien intelligence. Very important to remember the intelligence we have with artificial intelligence is not necessarily like human intelligence. Now that can be a problem and can make it confusing, but also remembering that helps us not to necessarily think we have to make them the same in order to be useful. I also think about appropriate intelligence. I'll talk a little bit more about this later, but crucially, any AI we produce works within a framework where there are people involved, not just the computer. And we want to optimize that complete system, the human with the AI, not just the AI. And also, it's sort of on that line, when we want explanations, when you talk to a human about things, the way they explain themselves is not to give every neuron's firing pattern in their head, but to give something that makes sense. And again, if we think about the interactions between people and computers, you end up with something far better than if you try and say, how can we make this AI totally explainable? So I'm not going to talk about all of those again, but we'll come back to appropriate intelligence later. One of the things I want to focus on, though, is these different styles of collaboration. How can people work with AI? So one way this can happen is we just tell AI what to do. So this is the sort of classic, Star Trek, computer do this kind of thing. And there's a lot of systems that are like that. You want something, you tell it what to do, you tell your Alexa to turn the dishwasher on, you want the dishwasher to turn on. There are, of course, times when it's the other way around. So something like Uber perhaps telling your drivers what to do. And maybe when you get hit by millions and millions of notifications, you feel like the AI is in control. And the boundaries between these can be a bit blurred. So it's not that any system fits entirely into those patterns. Arguably, the best thing to do is something that's not just between the two, but is perhaps more than the two. So one of the great visionaries in this sort of area was Licklider, who in 1960 talked about man-computer symbiosis. I think nowadays we'd say human or person-computer symbiosis. Now you could debate the biosis bit there, but it's about saying, can we use the complementary abilities of people and AI to work together, computers and people, to do the best that they can, each with their complementary abilities. So can we design for that kind of world? And let's move on to think a bit about that. So let's think about interacting with AI. So, and again, the kinds of applications, this might be from adaptive websites, perhaps the more sort of standard things that lots of people deal with, to perhaps if you're designing a semi-autonomous car or even a nuclear power station for that matter that's got intelligence and people in it. How do you interact with each other? So one of the first things to think about is abilities. You know, what are the different abilities? So you might look at, say, rote actions, large amounts of rote actions. We know computers are good at these and AI is good at doing this, versus perhaps more creative things. Now, again, this might change over time as computers change. Pattern finding, which we know machine learning is really, really good at, versus pattern interpretation. What does it actually mean when we see this pattern? So again, we can think about the abilities and how we share these out between people and computers. Perhaps even harder, though, than deciding which we're good at is how we do handover. Now, this is particularly difficult in physical cases like semi-autonomous cars. You know, when you want to physically hand over the driving from one to another. So we have to think about that, and there's different ways we can approach that. How do we gain situational awareness? If something's been happening autonomously, and that's true whether it's a physical thing like a car or whether it's a completely digital information world thing, how do we manage that the human can regain that situational awareness, that sense of what's happening? Crucially, actually, it's very easy when you design things, shall we say, from the computer out, to actually, at the point at which the computer thinks, yikes, I don't know what to do, to then say, okay, human, you take over. And of course, I think the car example makes it very, very clear that if suddenly you get the beep that says now you're in control, you're likely to have problems. The ability to make that more flexible in time, more flexible in who does what when, can help that a lot. And we'll see again some examples of this in a minute. So how do we design for this sort of world? You know, we've got these interactions, we're giving you some things to think about. How do we design for it? So I'm going to give you two heuristics here, and then we'll go on to some other sort of design issues later. So two heuristics here I'm going to talk about is deterministic ground. How do we know what might change in a system? And appropriate intelligence, so which I've mentioned before. What happens when it all goes wrong? So deterministic ground. Let's look at a menu here. So this is sort of very classic example, adaptive menu, sort of thing you see with fonts. So what you've got is an adaptive area at the top. So the parts of the people that the computer thinks you're most likely to want to send a message to. Perhaps the people you've most recently sent to, or the people you've most often sent to, have been put at the top. But crucially below that, there's an alphabetical list. So it's the deterministic ground, the thing that isn't going to adapt. And crucially, if you're going to have people working with systems where there is adaptation going on, the adaptation is important because it's easy to focus on that from an artificial intelligence point of view. But it's also crucial that people know what is going to adapt and what isn't. So thinking about the deterministic part, the bit that isn't adaptive, is as important as getting that adaptive bit right. So you might have another example with a different kind of deterministic ground. You might just highlight the items in the menu that you think the person is likely to want. So again, you've got a deterministic ground, an alphabetical menu, but what you're doing is you're making it very quick and easy to spot those frequent items. So different ways you can adapt that, but crucially making sure that that the user understands what is and is not going to change in their system. So that's one heuristic for trying to get some of these things right. The other heuristic I talked about is this adaptive appropriate intelligence. Now, imagine, you think about, I want to design a user interface that's using AI. So what you want is, for your demos, you want it to be right as often as possible. You want really, really good AI. And when it's good, you want it to do something that's really good for people. That makes a really good demos. This is what you want for the demos. Look how clever it is. Isn't it brilliant? However, I'm going to say this isn't the best way to design it. So I'm going to give you 3 rules for appropriate intelligence. The first one, it should be right as often as possible, of course. And when it's right, it should do something good. Absolutely. Even more important, though, is when it isn't right, it shouldn't mess you up. And you can put in your favourite expletive here rather than just mess you up if you like. So when it's right, when it isn't right, when things go wrong, it's crucial that you don't actually destroy things. And that's often what makes a system really work. The thing that stops somebody looking at it and thinking, I'm never going to use this again. And you've probably all had examples of this, where the system, where you're using a computer, and particularly with notifications, it pops up and thinks it's got something clever that you should do. It does a correction, perhaps a spelling correction for you. And particularly when you not notice the spelling correction, it might do something, you might have sent your mail out with some horrible thing in it. When things go wrong, they shouldn't be too bad. Really, really crucial. How do you design your intelligence with the user interactions to make that happen? Those of you who are of the older end might remember Microsoft Clippy, but this was a good old example of something that popped up and did things wrong. But the one that has survived, and that those who are younger will have never seen this because it hadn't survived because it didn't obey this. But Excel's sum button does this perfectly. You hit the sum button, it selects the area it thinks you want to add up. But if it's wrong, all you do is you select the area you want. The cost of it getting it wrong is really low. It has persisted and it is still there, and it's been there for probably 20 years or more. You can design for this. So back, and this is a .com US example, you probably see this from the icons appearing there. We had a system, I was involved in a small company, a intelligent toolbar that sat at the side of the screen and watched your clipboard. So how it worked, you were perhaps in the middle of an email message, as an email message before. You choose a word, you select the text, you copy the text, and on cue it was constantly, it was a little toolbar sitting at the side of your screen, and it was constantly looking at the clipboard. And if it saw something it thought it recognised, it would change. And the icons on it would slowly fade in. So if it was just a word, it would mostly be spelling checkers or thesauruses or search engines. If it looked like a table, it might offer you how to perhaps to copy it into Excel, perhaps to do some statistics on it. But crucially, the icons faded slowly. So it was on the side of the screen and the icons faded slowly. If they flashed in, what happened was your eye just got grabbed to them. So if you didn't want it, it would flash and suddenly you'd lose track of where you were. By fading in slowly, it meant that when you wanted it, it always showed the icons. But when it got it wrong, or when you didn't want it, it didn't get in your way. Okay. Let's look now at this cooperation in perhaps a bit more detail. So you can think about some of these heuristics, but how do we design this? So when you cooperate with people, you both adapt. And when we think about designing these interactions, we need to think both about how the AI adapts to the human interaction, but also sometimes how we adapt the user interface to make the AI work better. So let's look at the first of these, adapting the AI for interaction. If you want something to be fully automated, you look for the best or the safest AI, something that you want the decisions it makes to be absolutely best as possible. When you've got a human in the loop, you don't necessarily want that. Sometimes what you want to do is just make multiple suggestions rather than the single best ones, and perhaps inform the user about what the system thinks is best. So you go from that single best to perhaps having a better idea of what's good and maybe good. Example of this is I was working with musicologists, and they have these concerts, these are from 19th century, lots of newspapers, little statements about concerts happening, and they've collected loads of data from these. They went into all the newspapers, they find all the ones from the 19th century, loads and loads and loads of these, and wanted to match them up. So you could say sometimes there were multiple notices about the same concert. So what we did was designed an automated system that did automated matching, but in the end, they were all going to be checked by the musicologists. So the matching algorithm was quite liberal in the way it did matching. It did things, even things if which were vaguely similar, it would sort of push them together. But it also created very conservative warnings. So what it would do is, if they were absolutely identical, it would just put them in a group. It still had to be confirmed. But if one of these fuzzy groups was quite fuzzy, it would put a little bit of a warning sign, which would say to the musicologist, I think you probably want to give this one a little bit more thought. So because the human was in the loop, we designed the AI fundamentally differently. And crucially, actually, this is what the actual musicologist did, lots of bits of paper, lots of scraping. So sometimes you want to come out of the computer as well. But crucially, this is about designing something that works with people in their situation. And so finally on this side, so we talked about adapting the AI for people. So obviously we want the computers to work for people. But also sometimes you have to do the other way around. The best UI is obviously you want to give the user interface that's best for the user, and that gives you the immediate gain. But sometimes it's actually better to have the second best user interface if it gives you a better long-term gains. And we'll see an example of this now. This works at epistemic interaction is named after epistemic action, which is a sort of philosophical term, but refers to the fact that, there's Pandora looking at that box and she thinks, I wonder what's inside. Well, she doesn't just think, I wonder what's inside. She opens it. And in reality, we often have to do that peeking, do that action that uncovers something. Now, that's true about us looking at things, but we can turn that back the other way around. Here's two options. Imagine we've got a document search engine, and this is actually the one on the right is one for a human-computer interaction book that I have. So you search the book and it tells you about paragraphs and sections in the book that match your search query. So the standard interface you might think is just a scrolling one, a bit like a Google search. And this example, in fact, that's the way it does work. So you scroll down and you can see more results. But another option you might have is to have all results quite compact, and here we've just got one line of each result rather than the whole paragraph, and then a little plus button to expand it. So we've got an accordion style expand and contract type, fold and fold type interface. So there's two options. Which is the best one to have? So imagine we've done this. So perhaps what we've done is we send out and we do a big user test on these. Perhaps we deploy them. If we're Google, we deploy both and we do an A/B test. We get lots and lots of trace data. And imagine we found the scrolling interface is actually a little better. Flicking through is that little bit easier to do. It's a big thing to scroll through, but we're quite good at scanning text. So imagine that's a little bit better, but not a lot better than the accordion. However, the accordion gives more data, because when somebody clicks something to open it, they were interested in that. Now, if they fold it straight away, you also know they weren't interested as well, perhaps if it's very quick, and that in some sense the line they got that they see was perhaps uninformative. But we're getting quite a lot of information, whereas it's much harder with the scrolling interface to work out exactly where somebody's focus is. We know exactly what they're focused on. So the accordion gives more data for an artificial intelligence system to adapt and then perhaps produce something in the long run is better for the user. So there's a balance here, because obviously if the scrolling interface was better, it's got to be a lot more information perhaps to balance that. But if they're nearly the same, there's not much difference. We might use this to push our choice. So there we are. We've had, I've talked about lots and lots of things, but three takeaways I'm going to give you here. One of them is this deterministic ground. Make sure your users know what's going to adapt. If you're going to use AI to adapt a user interface, make sure they know what's going to change. Appropriate intelligence, tuning the user onto the AI to offer human alternatives, but crucially to fail well. If things go wrong, if the AI is not perfect, you want this to work as still not too badly. And an epistemic interaction, sometimes we might want to choose a user interaction pattern that isn't the absolute best, but actually gives more information for machine learning. Just like as people, we sometimes say extra things that we don't need to say. But in order to make things easier for the other person and to fuel that interaction, to make us work better together.